So I have some doubts that carbon dioxide is a greenhouse gas, and basically I want to be convinced of it. So I've been asking around. So far, no real firm things yet. For the most part, I've just seen assertion after assertion after assertion. It's a greenhouse gas, but there's never been a, how do you say, any kind of causality argument made. It's always correlation or look at this paper. And so anyway, I'm trying to do my own look around. First of all, I was tried to look up the specific heat of the thing. This guy says specific heat has nothing to do with the greenhouse effect. Well, right, that's true. Greenhouse effect has to do with absorption of infrared radiation. I'm not entirely sure I agree. Let's imagine a greenhouse. Let's see. If I have sunlight coming into this area, then that is radiation, and then it comes in, passes through, still radiation on the inside, and then it hits something absorbed by the floor, and then the floor releases infrared blackbody spectrum. IR blackbody spectrum, and then this surface it either absorbs or reflects the infrared blackbody spectrum, I believe. What else could it do? It can absorb or reflect it, or be transparent. So let me immediately acknowledge a kind of misconception of my own thinking, is that I was thinking of the infrared spectrum of carbon dioxide, and without considering that reflecting is whatever it reflects is not included in this, would not be included in its absorption spectrum. So that might be an important issue, because when you are using a greenhouse, the glass up here is probably, for the most part, not absorbing the infrared blackbody spectrum from the floor of the greenhouse. The glass is probably mostly just reflecting it back down to the floor. Let's come back to this video I've been commenting on in YouTube. Let's see if we can follow this discussion. I said, wouldn't it be a good idea to explore all inputs of heat to the environment? Carbon dioxide is also correlated with combustion engines, asphalt covering, farming, oil spills, and all kinds of other things that can heat the atmosphere directly or cause albedo changes of the planet, thus absorbing more light from the sun. As Anthony says, have I ever read the IPCCAR? All those things are considered. There's clear evidence for who causes the CO2 concentration to increase the fossil fuel burning, and also land use changes. Anyway, I went out to the IPCCAR. It was a big list of lists, and it was primarily, it seemed like mostly assertions, and not really so much explanatory. And I'm saying, if I ever saw something that would convince me, I'd happily become an anti-carbon dioxide fanatic. Unfortunately, most of what I've seen is infrared absorption curves of carbon dioxide, which suggest complete transparency, except for bands that are already 100% absorbed by trace water gases. If those absorption curves are correct, then the whole carbon dioxide footprint craze is nonsense, unless there is some other phenomena I'm overlooking. And so explain the theory from a causality standpoint and make me see it. So that's what I'm kind of trying to do here with the black body spectrum sort of thing. I want to understand why we got what is that? Nitrogen and water molecules in the air, and for some reason they're okay by themselves, but as soon as you add carbon dioxide, that this thing, I mean, it's different from these two. Carbon dioxide has most of its weight out at the ends instead of at the center, so it might be a little bit easier to access its rotational modes of motion. We've got a mass of 16 atomic units instead of 14, and they're a little bit further from the center. And if I understand properly, and I'm not at all sure that I do, the orbital, the angular momentum of these atoms is quantized, so you can have like one h bar or 2 h bar or 3 h bar, but you can't have like 0.1 h bar, and it's just a matter of it's like some of the atoms are going to be in this state and some of them are going to be in this state, but you're never going to have any atoms in that state. Now, I know there should be some kind of argument that I could make to relate this to entropy and maybe a specific heat at constant pressure, but no, that would be the thermodynamic properties of it, and they said that it doesn't have anything to do with the thermodynamic properties of it. It has to do with its infrared absorption spectrum. So I would like to continue to follow this later if I've got it recorded, so I'll remember to do it. Okay, I'll come back to this claim I made earlier. Most of what I've seen is infrared absorption curves of carbon dioxide, which suggest complete transparency except for bands that are already 100% absorbed by trace water gases. So I've got scholarly articles for carbon dioxide absorption spectrum. Let's look at the images. Okay, we got some pretty pictures here of graphs, and what do we find? What is this? Wavelength in micrometers right here. So if this is in micrometers, this over here is around 700 nanometers to 400 nanometers. This is the visible range. This is the thermal spectrum of the sun, I believe, right here. And most of those have that in it, the thermal spectrum of the sun, and which produces a lot of visible light, which is between 400 and 700 nanometers. So let's see about visiting that page for a moment, and how about that? It's the science of doom, evaluating and explaining climate science. Same thing I'm trying to do. So what do these lines mean? Do these represent where the most light gets through, or do they represent where most of it is absorbed? So CO2 absorption. So this is log base 10 of the intensity. What the heck are the units on this thing? Per centimeter, per mole, centimeters squared. Why would you have centimeters squared per centimeter? It says Planck 0, 5 overlaid carbon dioxide. Oh, this is Planck. This is called Planck's the Planck distribution. So that's why it's Planck. Which makes me ask the question: what are the units on the Planck distribution? The Planck. Well, I got something else there. Oh, this has intensity in arbitrary units. Let's see if I can do a unit analysis of this thing. This is just going to be, this all cancels out. This is just a factor, if I remember correctly. It's got to be, because this is just a 1 here without a unitless thing. So h nu over Boltzmann's constant times temperature is a constant. Planck's constant is this crazy number, square meters, kilograms per second. Now, am I remembering correctly that is the units for angular momentum? Angular momentum, I think L equals the moment of inertia times, no, that's not right. Yeah, radial velocity, if I remember right. And the moment of inertia is sum of mr squared times omega, which would be kilogram meters squared per second. Kilogram meters squared per second. Yes, so this is units of angular momentum right here. And then if I'm not mistaken, this is a nu, which is frequency. So we're going to take that h, which is in kilogram meters squared per second. We're going to multiply it by nu, which is over a second cubed, divided by c squared, which is meters per second squared. So that is kilogram meters squared per second to the fifth times, and I'll just take the reciprocal of this, second squared over meters squared, cancel those out, and we have kilograms per second cubed. Okay, that's weird. Not quite physically intuitive, is it? Kilograms per second cubed. And they've got the log base 10 of the intensity in centimeters per mole. So I don't know if that helped or not, but anyway, it's different units, so I'm not sure what that means. But anyway, it looks like this thing is getting something here. Does that mean it's absorbing something in the violet light range right here? And then, oh no, this is the right hand side. This would be the red. This would be over here, would be the violet over here in the 400 nanometer, and then this would be red, and then we'd be going into the infrared as we get higher and higher wavelengths. So yeah, it does look like this is really picking up quite a bit of radiation all the way along the way. And this isn't the graph that I've seen before. It seems like what I've seen was there was two graphs that were superposed on one another, having carbon dioxide and water basically in the same spot. Alright, let's look at these numbers over here. This is log base 10 of the intensity. So I believe that means that right here we're talking about something on the order of 10 to the negative 26 I'm not sure, absorptions, 10 to the negative 26 absorptions per mole, which is actually on the order of magnitude of 1 in, what, 10,000? 10 to the negative 23rd in a mole, so 10 to the negative 26 would be 1/1000th of that. So this would mean that 1/1000th of the atoms are absorbing light in that range. And up here you got 10 to the negative 20th, 10 to the negative 19th,